Hello class, today we are going to look at arcs and angles. Okay, so we're still looking at circles, we're going to look at arcs and angles. So first, a central angle, this is an angle whose vertex is the center of the circle. So for example, angle ADB. Angle ADB, the vertex is point D, right there. That is the center of the circle, so that is a central angle. An arc, what that is the set of points on a circle that are between the rays of a central angle. Okay, so this right here is an arc. And the way we would name this, we would call this arc AB, or sort of this. So AB, and instead of putting a segment or a line or anything like that, we're going to put an arc, like that, arc AB. Okay. Arcs are measured just like angles are measured. An arc's measure is the same as the measure of its central angle. So the measure of arc AB, so we're going to M and then AB. So the measure of arc AB is equal to the measure of angle ADB, which we can see right there is 80 degrees. So the measure of arc AB is also 80 degrees. All right? So not too bad. Pretty easy stuff so far. Now, next thing. There are different kinds of arcs. You have minor arcs. This is an arc that measures less than 180. Arc AB has a measure of 80 degrees, so arc AB is a minor arc. A major arc would be an arc that measures more than 180. And if you have a major arc, you have to be a little bit more specific in the naming. So for example, arc AB is a minor arc, but what if we go the other way? What if we go this way here? This is still part of a circle, right? It's in between the rays. It's just in between this way. This is an arc. This is a major arc. It is more than 180 degrees, right? Because the whole circle is 360. So the measure of this one is 360 minus 80. So that would make this, what, 240. 240 degrees. So the measure of arc, this big arc is 240, but I can't just call it arc AB, because otherwise how do you know, are you talking about the minor arc or the major arc? To name the major arc, what we're going to do is we're going to call this ACB. Okay, still with the arc there. Arc ACB. We have to say, what this is saying is that we're going to go from point A to point B, but we're going to go by way of point C. All right, we're not going to go the short way. We're going to have to go through point C first. We're going to go the long way through. So this is a major arc, more than 180 degrees. So what do we call something that measures exactly 180 degrees? Well, if it measures exactly 180 degrees, we call that a semicircle. So, for example, if we extended this all the way through like that, and we're looking at arc, this arc right here, all right? That is a semicircle. And again, I am going to, you can name this either as one with, you can either call this arc, not A, you could either call this arc BC, or you could call this arc BAC. You can actually call it either way. It is better if you call it arc BAC, because that tells you which side you're looking at. BAC is obviously going to be this arc here, because it has to go through point A. If you just say BC, you don't know which one you're using. Are we using the one over on this side, or are we using the one over on that side? We don't know. All right. So it's better if you have 180 degrees or more, make sure you use 3 points. Use that center point there. Use that point A. That way we know that it's a major arc. We know which way you're going. All right. Okay. So let's take a look at some of these. Let's do some examples here. So name a minor arc. Well, that's easy enough. We actually have several of them we can choose from. That's anything that's less than 180 degrees. So I will just say we have arc GI. That's a minor arc. Less than 180 degrees, quite clearly. We could also use arc HI, arc EG, arc EH. All of those less than 180 degrees, so they're all minor arcs. That's fine. Major arc, anything more than 180 degrees, so that could be arc Let's see, we go from G all the way up through to I. That would be more than 180 degrees, right? Now, I can't just call this a GI, because if we do GI, then we'd think we're looking at this one, going the short way. But we want to go the long way around, so instead I'm going to call this GHI. That's not the other one. I could call it something else. I could call it GEI. It would be the same thing. Go from G to I by way of point E, which is still going to take you through point H, right? Either way. I could also have a major arc, EIG. Would also be a major arc, right? All right. Okay, so let's see here. We want to name a semicircle. Well, let's see here. GH is a straight line, which means that that is 180 degrees. And so we could go either side of that. We could either go GEH or GIH. Either one is fine. I'll go GIH because why not? Notice, arc GIH is not the same as arc GHI. They're different things. The first one, GIH, starts at G, goes through I, and then to H. The other one, GHI, starts at G, goes to H, and ends at I. So they're two different things. So the order does matter a bit, all right? Especially if you've got something in the middle. Now, the first and last letters, those are fine, kind of like a segment. Arc, EH, arc, HE, either way, it's the same thing. But if you have three letters, then it does matter what order that. Okay, so now we want to find the measure of arc EG. Arc EG was EG. So EG is right here. The measure of arc EG is the same as its central angle, so that's easy enough. That is going to be 119 degrees, because that's what the central angle is, right there. All right. Okay, so let's see, what's the next one say? Find the measure of angle HFI. So angle HFI is right there. It doesn't tell me, but it's the same as the arc, right? The arc is the same as the central angle, so the arc is 82. Therefore, the measure of angle HFI is also 82 degrees. What's the next one? Yeah, find the measure of, that should be arc. And that also should be arc. Find the measure of arc EHG. Arc EHG. So from E to H and then around to G. So we want to find the measure of that. Okay, so this is going to take a little bit more work, but still not bad. Because, again, we know that this is a straight line. We can see that. So that means that's 180 degrees. I know this one is 82. I need to find the other ones. Well, I know that this whole thing here, that's 180, and I know that this is 180. So what I'm going to do over here, let's see, 180 minus 119, so that would be, okay, so this is 61 degrees, and this is 180 on this side, so I can just do 180 plus 61, 241. So this is 241 degrees. All right, so now what does it want us to find? Let's see here. We want arc EI. Where's EI? So EI is right there. Well, that's not too bad. That's 61 and 82. All right. And you can add up the measures of arcs just like you can add up segment addition, angle addition, arc addition. It's all good. All right. So that is that. Let's take a look at this. So here I have angle JMK. JMK is not at the center. This is not a central angle. This is an inscribed angle. An inscribed angle is an angle with a vertex on the circle and the sides are chords of the circle. So our angle JMK is an inscribed angle. Okay. Now, another definition right here, intercepted arc. An intercepted arc is an arc that is defined by the sides of an angle. So arc JK is intercepted by angle JMK because the sides of the angle hit that arc. That's where it hits the circle. That is the arc intercepted. And so what we could say is that, why did I not do that? There we go. So angle JMK intercepts arc JK. Angle L also intercepts arc JK, the central angle there. All right? And the reason I want to bring that up, so the measure of an inscribed angle is half the measure of its intercepted arc. So what that means is the measure of angle M is half the measure of arc JK. All right? So the measure of angle M is equal to 1/2 the measure of arc JK. Well, arc JK is 116, so we have 1/2 of 116, and so that is half of 116. And so the measure of angle M is 58 degrees, half the measure of the intercepted arc. Because again, the arc is the same as the central angle. So this is 116, and so the angle is half of that. Okay, so here we go. We want to find the measure of arc OP. So let's take a look at this. Measure of arc OP. So OP is right there. And so what do we know? We know 24 is angle ONP, right? Well, ONP is an inscribed angle, so it is half the measure of arc OP. So what we're going to do, if 24 is half, so we're going to double it, times 2. So that means OP is 48 degrees. All right. Now it wants us to find the measure of angle PQO. So PQO, that's the red angle there. Well, that's an inscribed angle. It intercepts arc OP, so that means it is half of 48, which is 24 degrees. So you'll notice angle ONP and angle OQP both have the same measure, right? Which makes sense because they intercept the same arc, right? So these inscribed angles both intercept the same arc, and therefore they have the same measure because it's half of the same thing, right? So what if I had another angle like that? What would the measure of that be? 24 degrees. It still intercepts that 48-degree arc, right? What if I had an angle like this? Still 24 degrees. It intercepts that same 48-degree arc, so it's still half of that. So, thing we can write down, any inscribed angles that intercept the same arc will have the same measure every single time. Doesn't matter where they are, if they both intercept the same arc, then they will both have the same measure. All right, now, what I want to do now, I want to find the measure of angle PRN. So that's the green angle there. Well, it doesn't tell us anything. Don't have any numbers, don't know what the arc is, except we do have segment PN, right? Segment PN goes through the center of the circle there, so that's a diameter. So it cuts the circle in half, which means this arc right here is half the circle. That is 180 degrees. PRN there is inscribed, right? And it intercepts the 180-degree arc. So it's half of 180, so 180 divided by 2, which is 90 degrees. So what if I did this angle here? Intercepts the same thing, 90 degrees. This angle here intercepts the same thing, 90 degrees. In fact, what we can put here, any inscribed angle that intercepts a semicircle, right, 180 degrees, that's a semicircle. Any inscribed angle that intercepts a semicircle will measure 90 degrees. Doesn't matter where it is. If it intercepts this semicircle like that, 90 degrees, 90 degrees, 90 degrees. All right. So, just to refresh, let's go back to the beginning here. A central angle is an angle whose centered in the center, whose vertex is the center of the circle. Arcs are a piece of the circle, and it has a measure that equals the central angle. Inscribed angles have a vertex on the circle right there, and their measure will be half the measure of its intercepted arc. So it's also half of that central angle. Any inscribed angles that intersect the same arc will have the same measure. And any inscribed angle that intercepts a semicircle will measure 90 degrees. Hopefully you found that useful, and I will see you in the next video.